Welcome to today's programming tutorial. In this video, we'll explore a Java program that generates random numbers and determines their order using the random class. Before starting, I would like to give you a disclaimer. The program given in the university practical book is lengthy, so by following the same concept, I have used a shorter version. I hope it will be easier for you to understand. So let's dive right in. First, we import the Java util package to use the random class. Then we define a class named random number distribution and declare its main method, which serves as the entry point for the program. Inside the main method, we create a new instance of the random class called random. This instance will help us generate random numbers. We initialize two arrays, AR with a size of 50 to store the 50 random numbers generated randomly, and count, a variable of type array with a size of 10 to keep track of the number distribution in each range. Now, let's move on to generating the random numbers. First, we display the message generating random numbers and determining their order. Then, inside the for loop, we declare a variable named random number of type int, which is used to store the generated random number at each iteration of the loop. To ensure that the random number is within the range of 1 to 100, inclusive, we initialize this variable with the expression random.nextInt of 100 plus 1. Let's break down this line. The method nextInt of 100 is called on the random instance, which generates a random integer between 0 and 99. Since we want the range to be between 1 and 100, we add 1 to the generated value. This adjustment ensures that even if the nextInt of 100 produces 0, we get 1 after adding 1, and if it produces 99, we get 100 after adding 1. For example, if the nextInt, 100, generates the value 42, it is definitely within the range of 0 to 99. By adding 1 to it, we get 43, which satisfies our requirement of generating a random number between 1 and 100. So we have taken the generated random number and place it in the ith slot of the ARR array. On the next line, which displays the value of random number on the console, accompanied by a comma and a space. Before moving further, let's take a closer look at the concept of the slice of 10. The entire range of numbers from 1 to 100 is divided into 10 groups or slices, each comprising 10 consecutive numbers. Here are the representations for each slice. Slice 1 represents the range from 1 to 10. Slice 2 represents the range from 11 to 20, and so on up to Slice 10 represents the range from 91 to 100. To keep track of how many numbers arrive in each group, we use a variable called count, which is of type array. Initially, all the values in the count array are assumed to be 0. The count array is indexed from 0 to 9. Whenever we have a count of 0, it represents slice 1, and a count of 1 represents slice 2, and so on up to count of 9 represents slice 10. To determine which group a random number belongs to, we use a variable called range index. The lineant range index equals random number minus 1 divided by 10, is responsible for finding the correct group or slice of 10 which a randomly generated number belongs. For example, let's consider the random number 40 for explanation. If we didn't subtract 1 before dividing, the range index would be 40 divided by 10 equal to 4, which corresponds to the fifth slice, 41 to 50. But that's not what we want. Instead, by subtracting 1 from the random number, we get 39. Then, 39 divided by 10 gives us 3, which corresponds to the fourth slice, 31 to 40. Now we get the correct group. In the next line, we have count range index plus plus. Let's break down this line into two parts. 1. Count range index. This accesses the value in the count array corresponding to the range index. 2. This is the post increment operator, which increases the value in count range index by 1. In our case, we have the count of range index that is currently containing the value 3. Now the first step is to go to count 3 to check what value it has. As you can see, count 3 is currently 0. The next step is to increase this value by 1 to reflecting the arrival of a new number. For this purpose, we use post-increment now. It become 1. Let's take another example. If we have a random number 36, we calculate the range index using the formula 36 minus 1 divided by 10, which gives us a range index of 3. We then check the value in count at index 3, which is 1. After using the plus plus operator, we increase it to 2, reflecting the arrival of a new number which is in the range 31 to 40. I hope you guys understood this entire concept. The count array keeps a running total of how many numbers have been placed in each group. In this program, you generated 50 random numbers, and for each number, you used the steps mentioned above to determine which group each random number should go into. As you can see, we have defined our ranges as 1 to 10, and so on up to 91, 100. To represent these ranges, our program has two variables, start range and end range. We begin by initializing the start range variable to 1. Then we employ a for loop to iterate through the count array, aiming to display the values stored within it. Iteration 1, I equal to 0, the loop starts with range start being 1. The condition 0 is less than 10 is true, so we enter the loop. Calculating the end range is straightforward. We simply add 9 to the start range. For instance, in the first group, 1 to 10, start range is already defined as 1. Adding 9 to it results in end range being 10. The message, numbers between 1 to 10 and the value in count of 0 is printed. Then range start is updated to 11. Iteration 2, I equal to 1. Now range start is 11, updated value from the previous iteration. The condition, 1 is less than 10 is true, so we enter the loop again. Range end is calculated as range start plus 9, which is 20. The message, numbers between 11 to 20, and the value in count of 1 is printed. Then, range start is updated to 21. Iteration 3, I equal to 2. Range start is now 21, updated value from the previous iteration. The condition 2 is less than 10 is true, so we enter the loop. Range end is calculated as range start plus 9, which is 30. The message, numbers between 21 to 30, and the value in count 2 is printed. Then, range start is updated to 31. Understood, guys? For each value of I, you can iterate through the loop. To keep the video concise, some iterations have been skipped. Please refer to the provided table if you have any doubts. Now I will explain the last iteration. Iteration 10, I equal to 9, range start is 91, updated value from the previous iteration. The condition 9 is less than 10 is true, so we enter the loop. Range end is calculated as range start plus 9, which is 100. The message, numbers between 91 to 100, and the value in count 9 is printed. However, after this iteration, I becomes 10, and the condition 10 is less than 10 becomes false, leading to the termination of the loop. And that's it. You've just learned how this entire concept works in Java. I hope you found this explanation helpful.